I'm not sharing out with them yet, am I? Okay. That's probably important. Okay, now I'm sharing out at home. So did we skip one too? Shoot. What one are you guys working on right now too? Okay. So go to page, whatever page this is that we left off with yesterday, page 31. So go to page 32 and do number 2. And what I was showing before I realized I wasn't sharing my screen is what I want you to do is put dots at the end of these so we know where this graph starts and where this graph ends. Don't put little arrows saying that those go on forever. And then identify your domain range. What are our intercepts, location, and value of the max or the min, all that good stuff. Let's see where we are at here. I don't want to spend too much time waiting just to make sure we get through everything I want to make sure you need to see before Thursday. The domain are your x values again. So just what x value do we start at? What x value do you end at? So by me telling you to put a starting point right here, then we would just come on down to the x-axis and we would see that we start at the x value of a -6. Since I have a closed dot there, that's when we would have used our brackets. And then this graph is a solid graph the entire time. So we're going to hit every x value until we stop. And we don't stop until we're over here. And then that would have been what? 6, 7, and 8 would have been where this graph stops. So we hit every x value between a -6 and a +8. All right, thanks, Bisher. I've been there, buddy. I've been there. The range is our y values. So now we look, what's our smallest y value? So this y value right here, our smallest y value is 3. So that's where we start. And then since I told you to stop at these 2 dots, our largest y value would have gone up to the 10 right here. So we'd say 3 to 10. Now, intercepts, what I'm looking for specifically when we say the intercepts, when we're talking about these, are the x-intercepts. All right, does this hit the x-axis at all? Does it hit it anywhere? No, so we wouldn't have any x-intercepts. If I did ask for the y-intercept, so in terms of our y-intercept, we do have a y-intercept. The y-intercept is the y value of 4. All right, typically when we start talking about intercepts, that's referring to x. All right, within the context of these. All right, this one, location of max or min. So in this case, we have each, right? We have a maximum value of y equals 10. That's why our range finishes up here at 10. No, I just crossed it out. And then it's asking, where does it occur? The location just means we would then say at x equals. So notice how we hit the value of 10 over here at the value of a -6. We also hit the y value of 10 over here at 8. So we actually have 2 places where we get that y value to be a 10. And then we definitely have a minimum. That should also be the beginning of our range, right? 3. That's our smallest y value. And then that would have hit the x value or the y value of 3 right here at this x value, which is 1. So at x equals 1. All right. All right, the increasing and decreasing intervals. So if I do the increasing interval, we should be able to visually look at this. Then it's just a matter of remembering to write this. So here's where we clearly are going up, uphill, uphill in here. So we now just want to write this in interval notation, and that's always referring to x's. So when you would have done these the increasing interval is always the interval for x. So if we look at the yellow that I have highlighted here, that interval starts at the x value of 1. That's where we start to increase. So let me define this as our increasing interval. So that starts at the x value of 1. And then we continue to increase until the very end of our graph. And we've said the end of our graph is this dot. That's the x coordinate of 8. So we increase over the interval of 1 to 8. If we see where we decrease, that would be the other side of this graph. So here. So then we just want to define where does that blue interval start. So it starts at this dot. The x value there was this -6. And the blue is solid all the way until this shared point, which we should now be very familiar with, that vertex point, and that has an x value of 1. So we decrease in that interval. Okay, that's old. That's very, very beginning of this chapter, and that's actually a review from last year. We did a little bit of it right before the end of the semester, last semester. All right. Now, I didn't mean to skip number 1. There's no reason for us to skip number 1. So pop up to number 1. And now that we have done one of these, let's do this. And now let's do it this way. Since I told you to stop the other one, now put arrows on this one. So let's now pretend that does go on forever. And then do all 4 of those. See if we can answer these things real quick. All right, give you one more minute here. If you're not quite done, we'll get you all caught up here. All right, let's see where we're at here. So our domain, our x values, now that we put these little arrows, we did a ton of these parabolas at the end of last semester. We had the domain and range of these down pretty well back then. So the arrows, even though it shows them going downwards, this would also continue to go to the left forever. It's all slowly, but this will go to the right forever. So our domain, when we dealt with all of those, if you remember, was always negative infinity to infinity. That hasn't changed, right, for all the ones that we've talked about because of those arrows. The range, that's your smallest. So our smallest y value to your largest y value. So if we start talking about the smallest, if this thing continues to go down forever and ever and ever, we would have talked about how do we ever really hit a smallest value, all right? And the answer to that would be no. So there is no smallest value because we continue to go to negative infinity. We go down, 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 more and more and more and more and more. We do have a largest value, and that would be the y value of -1. And since we actually hit that value, you would need a bracket right there. So that's our domain, left and right forever. And then we go down forever, but we only go up to the -1. Similar to our last graph, there are no x-intercepts. We don't touch the x-axis at all. And then our y-intercept is right here, just so happens to be our vertex. That's the y value of -1. When we do our range up here, so when we did our range up here, smallest to largest, in many ways we're answering this question at the same time. So if -1 is the biggest number in our range, that has to be your max. So that's got to be the y value of a -1. And if we say that our range starts at a -infinity up here, then that would mean minimum wise, there isn't one. We just get smaller and smaller and smaller and smaller. Okay. Y equals a -1 occurs at the x value of 0. And since we don't have a minimum, there is no location. We don't need to add the location of a minimum if we don't actually have a minimum. All right, then we do our increasing, decreasing. So here's where we go up. Don't be fooled by those arrows. This is when we would be going uphill. We always want to talk about increasing and decreasing as we move left to right along the x-axis. So this is where we're moving uphill. So that should have started at a -infinity as well. And we continue to go up, 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 up until this point right here, which is the x value of 0. Once we hit that high point, now we start to fall. So we're going to go down, 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 down. So we're going to decrease the rest of the way. So then starting at 0, where we switch, we decrease forever after that. So from 0 to infinity, we are going downhill. So we'll be able to answer that. I don't know if we'll ask all of those, but certainly, some elements of that we want to make sure that we remember. Okay, it wasn't the focus of this chapter, but certainly things that we want to know how to do for a while. All right, let's see here. How do we handle this? Yeah, I want you to try to graph this real quick. So just make a cheap little XY plane here, left some space. I think this is probably your best way to answer this question. So I didn't make you graph a piecewise function on the quiz that you took last Wednesday. Reasonable chance, because I didn't do it on the quiz, that you're going to have to do it tomorrow. So as best you can, see if you can graph this. So always kind of remember the two things that we always know. What's the point that's getting shared? And what is the slopes? Because we always get two different slopes. Plot the point and then graph your slopes. And then all of this should kind of take care of itself. The domain, range, intercepts, the max, mins, all of that. We've already done them when we know the graph. Once we have the graph, we should be able to answer these. The key with this is making sure that we get this point right. So if you're not sure which point to start with and plot based upon these equations, you may want to hang tight, but I'd like you to at least plot the point and see if you understand maybe what that would be. Anybody in here think they know this point that we need to plot? What do you think, Cam? Good. So the point that Cam said should be the point -3, and the reason he got that is he looked in the parentheses. So look inside of the parentheses here. See how this is an x plus a 3? That's telling us that our x coordinate is a -3. Then there's nothing being added or subtracted on the back end of this. So that would imply the reason we don't have to write that in is because it would have been a 0. So the y coordinate of that point would have had to have been a 0. So that's the point that we want to plot. And then I don't need this to be a perfect slope of 1 and a -1. But if I have a slope of a +1, right, here's the negative in front. We just have a 1 right here. So we're -1, +1. If we just draw in kind of a quick little sketch for the sake of answering these questions, one side we should have a slope of a 1, and the other side we should have a slope of a -1. Having that should now make the domain, the range, the intercept, all this much, much easier. Okay, so our domain, if we look, wouldn't this have to go left and right forever? Our range, our lowest, smallest y value is at this point right here. That's on the x-axis, so that's the y value of 0. And then we increase forever. Our x-intercepts, we have one now, finally. And it's just this point right here. That's the x-intercept at a -3. The y-intercept, you may have to think a little bit. You may have to know a little bit of math and such. I wish I had a good coordinate plane here, but think about if I'm starting here and I'm going to go up 1, right 1. That would have been my next point. Up 1, right 1. So that was 1. Here's 2. If I go up 1, right 1 one more time, the y-intercept would have had to have been 3. Now if I ask you the max, now we can see, doesn't this one go up forever and ever and ever and ever? So because that's going to continue to get larger and larger and larger, now we have no max. We definitely do have a minimum value. Just look at your range. Again, we're really, when we do the range, you're answering these two questions, right? So the reason I have an infinity right here is because I don't have a max. Since my beginning of the range is a 0, that means that's my min. And then that occurred at the x value of -3. Where are we decreasing? When we have a negative slope, right? So really, see this here? Here's where we have our negative slope. We could actually just look at this interval right here. If we've been doing it in interval notation, but if you just gave me this interval, isn't that when we have a negative slope? I would take that. That's when you decrease. If you want to say negative infinity to that, perfectly fine. Right here, when we're greater than a -3, isn't that when we have a positive slope? That's when we're going to know we're going to go upwards. So we could then say when x is greater than or equal to a -3, that's when we're going to increase. Or you can keep doing the parentheses in the bracket. Totally fine. Okay, last ones, and then we'll see where we're at after this. I haven't done this to you yet, but you know the little thing on our quiz test thing that I sometimes do? I can have you draw stuff in. So you might see something like this. So it says write a function that meets the following requirements. So write any function that is always increasing. Let's see what you think. So write a function. Doesn't have to be an absolute value function. Or, sorry, always decreasing. So what I'm getting at, just say f of x equals, and then whatever you put over here, I should be able to look at that. And if we were to write a decreasing interval, it should be everywhere from a -infinity to infinity. Okay, anybody in here got that? Yeah, we got Cam. You're making it up right off the top of your head, Cam. All right, so Cam wrote the equation. Notice how we're doing parentheses here. That means this is a line. And as long, and this is what I would have done too. I would have written a line. So basically what the easiest thing to do is to write a line with a slope that is negative. And that's what he just did. Here's our slope. It's a negative slope. Our point would have been -3, -4. You really could have done anything you wanted over here. So he used -3, -4. If it were me, and everyone's lazy at the most and we want to do the best we can with the least amount of work, we could have just thrown -2x, right? That's always going down, right? That's a function that's always decreasing, okay? Here's what number 5 is getting at. So you're going to write a function that is symmetrical around the line x equals 3. So hopefully we've done enough of these where wherever you have y equals a number, that means you have a horizontal line. Now we've done quite a bit in this chapter. If I just have x equaling a number, which we do right here, that means this is a vertical line. So here's what this is getting at. The two that we've dealt with the most, we just did up at the top of this paper. So don't I have a vertical, can I draw a vertical line right here through this vertex of 1, and isn't the right-hand side and the left-hand side symmetric to this line? So every v, every absolute value equation we've done will have symmetry about a certain line. Same with our parabola, right? This is when we actually started with the axis of symmetry is what we called it. I have an axis of symmetry right here where the blue side and the yellow side are symmetric around this line. So what you're probably, I think the safest thing to do is to write the equation of either a parabola, and if you want to do that, fine. I'd somewhat prefer you to do an absolute value since that's what you're most familiar with right now. That's what we've been doing for the last 3.5 weeks. Write the equation of an absolute value function that the vertical line x equals 3 would go right down the middle, and see if you understand how we could do that. Here's the bigger hint. Here's the general form for our absolute value stuff. I think the absolute values are the easiest way. And the key, here's the biggest hint. The key to this is, oops, of course didn't switch over in time, is this value right here. The slope, the a out in front, our slopes don't really matter. Where our y coordinate is, it doesn't really matter. It definitely matters what our h is. Because what's our h have to be, Cam? Got to be 3. Everything else does not matter. So if I draw a cheap little sketch of this, so I'll put a 1 right here. Doesn't matter. But that gets me over to 1, 2, 3, and then 1. I'm going to say my a, will make it simple, is just a positive 1. So then when I have a v going up 1, right 1, up 1, left 1, and then now 3, wouldn't my line of symmetry or axis of symmetry go right through this point? And that's what we just done. A function who's symmetric about that vertical line x equals 3. Okay. All right, the last one of these I want you to do, yeah, that's pretty tricky, is number 7. Because I'd like you to do this with an absolute value equation again. So go to number 7. This will be the last one we do out of this packet. And again, as a hint, the function I really like you to use, so just let the cat out of the bag already, is an absolute value function. So try to write an absolute value function. So here's what it looks like in general notations. That would increase from a negative infinity up until 2, and then decrease from 2 the rest of the way. So we go up and then we go down. So these are nice problems when we're actually in person and you can kind of talk with each other and we can kind of walk around and help. But alas, we don't quite have that. So see if you can do this real quick and then we'll see if you got one. That's bad. Didn't do it, Mr. Kulitz. It's kind of hoping it would turn it into a line when I did that. You got an answer, Ahmed? All right, so Ahmed put a 1 in front. And then you did x what? X minus 2. And then you did plus 2. So my guess is when I do this, most of us can graph this pretty well, having seen your quizzes on all of this. So let's sketch a quick little graph and see if Ahmed is correct. His point would be the point 2, 2. So 1, 2, 1, 2. And then his slopes would be 1 and negative 1. And since it's a positive 1, we would open upwards. So we would do up 1, right 1 to the right, up 1, left 1 to the left. So now let's see if what he said is correct. Are we increasing from a negative infinity, so from the left up until 2? So in this interval right here, we need to be increasing. Is that happening? No. But Ahmed's going to fix it. He's going to think right now while I show this, and he's going to fix this very, very quickly. We should have been decreasing from 2 the rest of the way. Are we decreasing the rest of the way? No. So do you know how you very, very quickly fix? Say that again, Ahmed? Good. So then he understood all we have to do to make this work is to throw a negative in front of our 1, because now I would have had a v that increases and then decreases like this guy does. Then we are good. So the keys here, you just needed a negative number in front. He picked a 1. That's probably what I would have picked because it's the simplest. This has to be x minus 2. This would not have mattered. It wouldn't have mattered where we actually plotted the point. As long as we increase and then decrease, that's what this was asking us to do. All right. All right, this actually works out pretty good. That way, if you didn't have the sheet, you can print that off for tomorrow. Yeah, we'll do these tomorrow. We've got a little over 2 minutes. So we'll do 10. We'll do 1 or 2 of these tomorrow. And then from there, we will jump to that new one that I have. And then you guys already have it printed, so that's easy for you guys. All right. So we will call that a day. Again, test is now Thursday. It is not tomorrow. So just make a note of that. Make sure we're aware of that. And then we will